Hey, this is chapter 9.5. We're going to be covering our final conic section, the hyperbola. So the standard equation for a hyperbola is x squared over a squared minus y squared over b squared. And the difference between this and that of the ellipse or circle, you'll notice that we have a negative sign instead of a plus sign. So in terms of our graph, A is the distance from the center to the vertex once again. So we have our points A0 and negative A0 for our vertices. Our foci, once again, are C. So we have C0 and negative C0. This time the foci lie on the kind of inside of the curve of our two branches of the hyperbola. And our B value is going to help us make our rectangle here, which is what we are using to draw our asymptotes, which form the curve of the branches. Once again, we have a we have an axis. This time it's the transverse axis, which runs through the center of both hyperbola. So once again, like we had with the ellipse, our hyperbola can have branches that are in the opposite direction. So if we do a new graph, we can have our hyperbola opening up and down instead of left and right. And so our asymptotes would be like this. This is a very rough sketch. And yeah, so that kind of equation would have that kind of graph would have the equation of y squared over a squared minus x squared over b squared equals 1. And this is different from the previous one in that our y squared is positive and our x squared is negative, whereas previously we had x squared over a squared minus y squared over b squared, and our x squared was positive and our y squared negative. So looking at the standard equations of our two types of hyperbolas. So as I just mentioned, one of them will open left and right, and the other will open up and down. So if we go back and look at our equations, once again we have our positive x and our negative y, and our positive y and negative x. This one will have, so once again the one on top of this table is the one that's opening left and right, as you can see. And this one has a horizontal transverse axis. So our axis will be going through the hyperbolas. And our asymptotes, we have the equation of y equals plus or minus b over a x. Our vertices we'll find with plus or minus a0. Now for our second type of hyperbola, it has a vertical transverse axis. So once again, this is going through the branches, and then we have our asymptotes, which are y equals plus or minus a over bx. So this one is b over a, this one is a over b, and our vertices are 0 plus or minus a. These make sense because if you think about where the vertices are on here, they're going to be on the x-axis, whereas on this graph, our vertices are going to be on the y-axis. So this makes sense with our coordinates. So we're told to graph 25y squared minus 4x squared equals 100. Furthermore, we're told to identify the vertices, foci, and asymptotes. So like we did with our other types of conic sections, we're first going to find the standard form of this equation. We're going to do that by rewriting our equation as y squared minus x squared, y squared is over 4 and x squared is over 25, equals 1. So once again we've divided by 100, and therefore we have our equation, and from this we can identify our vertices, foci, and asymptotes, which is our second step. So a squared equals 4, therefore a is 2. B squared is 25, therefore b is 5. Now, since our y term is the positive one in our equation, we are going to have a vertical transverse axis. So moving on from our a and b values, these tell us that our vertices will be at 0 plus or minus 2, and this just means that we will have 0, 2, and 0, negative 2. it's just easier to write with plus or minus. Now our b values are going to tell us that our foci we can find with the equation c squared equals a squared plus b squared. Therefore, c equals root 29. This is using the same concept of the Pythagorean theorem from a right triangle, except that rather than having the a as the hypotenuse, as with an ellipse, the hypotenuse is the c value. Finally, we're going to draw a rectangle for our asymptotes. The rectangle is 2a high, or the length is 2a, and 2b wide. Therefore, we have 4 units and 10 units. So generally we'll be having, we have 4 units and 10 units. This is a rough sketch, and then we will be making our asymptotes through this rectangle and therefore drawing our curves. So this is our hyperbola, and we can identify our vertices at 0, 2 and 0, negative 2. Our foci lie at root 29, which is approximately 5.4. So this will be 0, 5.4 and 0, negative 5.4. So I'll do that in red. And we actually don't have these complete points on our graph, but it would be something out here and out here. So the foci lie on the inside of the curve of our vertices. And our asymptotes. So I actually drew the rectangle wrong before. It should be a horizontal, not vertical rectangle. So this is wrong. It will actually look something like a rectangle like this. And that is what created our asymptotes, which run through here. So our second type of problem is to write an equation of a parabola with foci of negative 4, 0, 4, 0, and vertices of negative 3, 0, and 3, 0. So just in general, to kind of know how to visualize what our hyperbola will look like, we have our points on the x-axis. So therefore we know that we have a horizontal transverse axis with the center at the origin. From these points, we can gather that c equals 4 and a equals 3. 4 and 3. Next, we can find b by plugging in b squared equals c squared minus a squared. So we have 7. Therefore, our equation is x squared over 3 squared minus y squared over 7 equals 1. Therefore, we have y squared over 9 x squared over 9 minus y squared over 7 equals 1.